Hello everyone, today we want to go through some specific heat capacity problems. Firstly, I start with the content. I briefly explain that if you want to calculate the amount of heat required to increase temperature of something, or the amount of heat that something loses to decrease its temperature, we can use the formula Q equal mc delta T. That in this formula, Q is the amount of energy required or being lost by something, that the unit of energy is joule. M is the mass of that substance, that is kilogram. And delta T is change in temperature, that always when you see delta, it means this final one minus the initial one. And then if you want to find the unit of C, just C equal from here Q divided by M delta T. So this one is joule, this one mass is kilogram, and temperature Kelvin. So the unit for C is joule, kilogram, Kelvin. So remember, when you put the numbers in formula, your Q is joule, your C is joule kilogram per Kelvin, and then joule per kilogram per Kelvin, and delta T change in temperature, that it might be in Celsius or Kelvin, doesn't matter, as long as they have same units. So right now we go through first example. I think it's a good idea to pause the video, think and answer the question by yourself, and then check your answer. Calculate the amount of heat needed to increase temperature of 500 grams of water. So something that we do for physics problem, we always need to summarize the question. So I write M, mass equal 500 grams. What's my substance? Is water. So I write water because it's important. Then I know C that I need to use is C of water. And what else I have? I have initial temperature T1, that is 25 degrees centigrade. And I have my T2, that is 100 degrees centigrade. What I'm going to find, calculate the amount of heat needed. So Q is something that I'm going to find. So I have my C, I have mass, I have T1, I have T2. After that, we need to think about which formula we're going to use. The formula that we are going to use is Q equal mc delta T. Then we check our units. We know in this formula Q is joule, C is joule per kilogram Kelvin, that is correct, the unit that we have. Delta T, both in Celsius, so they have same units, okay? And mass should be in kilogram, but our mass is in grams, so we need to convert it to kilogram by dividing that by 1,000. Okay. Right now, our units are correct. We wrote our formula. We have summary of question. The only thing that we need to do to substitute numbers. So Q equal M 0.5 C, that we have it in the question, and delta T that we know is T final minus initial T. So it means 100 minus 25. So as the result is 0.5, 186 times 75. If you put it in your calculator, you get this answer. And you see your answer is positive, and the unit is joule. You don't forget to put your unit. The answer is positive. It means the object or substance actually gaining heat. If the substance loses heat, your answer becomes negative. Okay, let's go through the second question. Again, please pause the video, answer by yourself. After that, check your answer. Students add 200 grams of cold water. So I start M1 is 200 grams with a temperature of T1 15 degrees centigrade to 300 grams of water. So M2 is 300 grams of hot water with temperature of 50 degrees centigrade. What will be the final temperature of water when thermal equilibrium is reached? So we want T equilibrium. So right now, and the substance is water, both of them, so just we need C of water. First, let's see if we did understand the question. So we have a container of water. The temperature of this one is 15 degrees centigrade, and we have 200 grams of water in it, 200 grams. And then we have a bigger container. In this one, we have 300 grams of water, and its temperature is 50 degrees centigrade. Something that we are doing, we add this water to this one. Definitely, when we add these two, after a while, they reach to equilibrium, to the point that we name it thermal equilibrium. But what happens to this one? Because temperature of this one is higher than this, it means this container, water of this container loses heat, and this one gaining heat. So as a result, this one gains heat and its temperature increases. This one loses heat and its temperature drops by the time that they get to thermal equilibrium or same temperature. But the amount of heat that this one gains is equal to the amount of heat that this one loses. So this one gains, this one loses. If I name this one Q1 and this one Q2, they have same magnitude, but Q2 is smaller than 0 because it loses energy, and Q1 is larger than 0 because it gains energy. So same magnitude, different sign. As a result, we can say Q1 equal minus Q2, or easily saying Q1 plus Q2 equals 0. Okay? So this is something that's really important. If you want to answer this question, you need to know this one. What else I need to do? I haven't checked my unit. M1 gram, I need to convert it to kilogram. And also I need to convert this one to kilogram. Right now, because I know Q1 plus Q2 is equal 0, firstly I write my Q1 and my Q2 equation, and then I add that. So firstly, this is common equation that I want to use, MC delta T, and in this case, I want to use MC, and T final actually is TE, minus T initial for each one. So Q1 is 0.204,186, and delta T is TE that we don't know it, but we know initial temperature for first container was 15. Q2 is equal, again, mass times V, okay? TE, again, because it's final temperature for both of them are the same, so it doesn't matter. When we say Q equal MC delta T, that is T2 minus T1. T2, when they get to thermal equilibrium, is the same for both of them. And that one, we name it TE, T equilibrium in this case. and initial temperature for second container was 50. And we know Q1 plus Q2 equals 0, just I add this 2 and I equate it by 0. So I say 0.224186 TE minus 15 plus 0.334186 TE minus 15 is equal 0. Right now, just we need to use some math to find our TE. So if I simplify this with this by another side, so right now I have 0.2, just I times 0.2 in here, 0.2 times TE minus 0.2 times 15, that is equal 3 plus 0.3 times TE minus 15, and so I factorize this one, so I put all of them here in 4186, all equals 0. Okay, just I factorize this one because it's the common between them, and then I can say that 4186 0.5 TE minus 18 equals 0. As a result, 0.5 TE minus 18 equals 0, and TE equals 36 degrees centigrade. Okay, just remember here, I made the mistake, I said this. Just simplify this to know, we factorize this one because they are both at the same side. We factorize this one and we write it times this one in this bracket and it times this in this bracket. Okay, I hope it helped. Bye for now.